Hello, my name is David Formby, and I am co-founder and CEO of Fortiphyd Logic. Today, I will be sharing how we are helping to secure Navy industrial control systems by using network traffic analysis and advanced machine learning to detect stealthy cyber attacks and costly maintenance issues. Fortiphyd Logic provides cybersecurity solutions for industrial control systems, or ICS networks. ICS networks are the foundation of the nation's critical infrastructure, controlling large-scale industrial processes ranging from the power grid and water treatment facilities to manufacturing and rail transportation. Cyber attacks on these critical infrastructure networks can have devastating economic and human consequences, making them high-value targets for our enemies. Fortiphyd Logic equips operators of these ICS networks with the tools and training they need to defend themselves against nation-state level adversaries and compromised insiders. Our virtual training environment gives defenders hands-on experience practicing real-world ICS attacks and learning how to defend against them. Our intrusion detection system uses advanced machine learning to detect cyber attacks and maintenance issues before they cause physical damage. Fortiphyd Logic is based on technology developed during my PhD research at Georgia Tech under my advisor, Dr. Rahim Bia. As I was finishing my PhD, Dr. Bia and I looked out at the state of ICS security solutions on the market and the growing threat of devastating attacks on critical infrastructure, and we decided to help defend them by starting a company and commercializing our technology. Even though we come from an academic research background, we are already making significant progress in transitioning our technology into real solutions. We are currently in Phase 2 of our NAVSEA CYBER, where we are developing patent-pending intrusion detection techniques that will help secure shipboard control systems from cyber attack. We were also awarded a Phase 2 CYBER from the U.S. Air Force to develop our virtual training environment, which is now a successful product on the market. The challenge that the Navy asked us to solve in this CYBER is that ICS networks simply cannot be secured by standard cybersecurity solutions. This is because ICS networks run on obscure network protocols that most cybersecurity solutions do not understand, making it near impossible to identify suspicious activity aimed at the ICS assets on the network. ICS devices also often run on embedded real-time operating systems, making it impossible to install any kind of normal antivirus on those devices. And finally, ICS networks are a unique target where attackers are not just trying to steal data, they are trying to cause physical damage. To secure the physics of a system, the solution needs to understand the physics of the system. While industrial control systems are found throughout industry and all branches of the military, they are especially important to the Navy. ICS networks control all the shipboard power generation and distribution, as well as the freshwater generator, engine, steering, and propulsion systems. To protect ships from disruptive cyber attacks, the Navy needs a solution to alert defenders of cyber-physical threats to their ICS. In order to protect against cyber-physical threats, the solution needs to detect both cyber and physical anomalies. In addition to all the standard cyber threats, the solution must understand the obscure ICS network protocols and monitor for unusual ICS commands and new or modified ICS assets. More importantly, the solution needs to understand the physics of the system being protected. Advanced adversaries can potentially evade detection through standard cyber means and use the legitimate control system to push the physical process into an unsafe or degraded state. The ideal solution would be able to monitor and understand key aspects of the physical process and alert operators when the system is close to failing or is operating poorly. Beyond just the Navy, there's a large need to secure ICS networks in other branches of the military and defense-related industries. Every military base has power and water facilities run by ICS networks where adversaries can disrupt operations with a power outage. The DoD supply chain relies on privately owned factories that can be targeted for both espionage and sabotage. Finally, supply chains can be disrupted even further with targeted attacks on fuel refineries and distribution facilities. To solve this challenge, we created a network intrusion detection system purpose-built for industrial control systems featuring novel anomaly detection algorithms for both cyber and physical behavior. For cyber anomalies, our technology focuses on the industrial controllers on the network, which are the final bridge between the cyber and physical worlds. These controllers are continuously reading sensor values, processing those values through some control logic, and then updating physical actuators based on that logic over and over again, hundreds of times a second. Our technology monitors the behavior of these programs, baselines what normal behavior is, and then alerts operators when that program starts to behave differently. The key advantage to this approach is that we can detect attacks and changes to the controller that would otherwise go undetected, even from a legitimate insider with physical access to the controller. In this case, a trusted insider can bypass any other solution looking for attacks only on the network by simply walking up to the device, physically plugging in, and launching an attack. However, our solution, using an agent on the controller and advanced machine learning, can detect when the controller has been modified regardless if that change happened over the network or from physical access. The second half of our solution focuses on the physical process being protected. Here, we monitor the physical measurements of the process, use machine learning to baseline what normal behavior is, and then alert when we observe behavior that is different from what we saw in that baselining period. The advantage to this approach is that not only can we detect stealthy cyber attacks on the physical process, we can also help detect maintenance issues and avoid unexpected downtime. Our technology is currently at a technology readiness level of 5. To develop our technology, we have been constructing small-scale physical testbeds representing various control systems on a ship to provide us with a source of safe and repeatable data to train and refine our algorithms. For the first major milestone, we built a small-scale demonstration of the central cooling system for ship engines. Working with the data from this testbed, we were able to achieve a TRL level of 3 last March. The next major milestone involved building a demonstration on a small-scale freshwater generator, emulating the system that distills freshwater from seawater using the heat from the engine. Working with the data from this testbed enabled us to achieve a level of 5 last October. The final major milestone to bring us up to level 6 will be demonstration in a full-scale commercial partner network. While our in-house testbeds provide safe and repeatable data, they are not as complex as most real-world networks, so we need data from those real networks to ensure our techniques can handle that level of complexity. We are actively looking for more partners who will work with us on this stage and help us to achieve level 6 by this October. Our key advantages and benefits can be split into 3 main features of our solution. First, Fortiphyd Host is our lightweight endpoint protection for industrial controllers. These industrial controllers run on obscure real-time operating systems, making it impossible to install any kind of standard antivirus program. However, our Fortiphyd Host solution can be easily installed, making it the only solution that can passively detect insider attacks on controllers. Second, Fortiphyd Process Anomaly Detection is our approach to use machine learning to detect anomalies in the physical process. This feature helps detect extremely stealthy cyber attacks, as well as help predict maintenance issues to avoid unexpected downtime. Finally, Fortiphyd Network is our ICS-focused network monitoring and intrusion detection system. This feature understands ICS protocols to look for ICS-focused attacks and track ICS vulnerabilities. To bring our solution to market, we plan on transitioning directly to Navy ships. The solution can be deployed on standard off-the-shelf hardware. This hardware is then installed on Navy networks to watch all of the network traffic and perform all the analysis and detection locally. The solution can also be sold directly to major prime contractors who have ICS networks that are high-value targets. Finally, we plan on selling directly to private companies and utilities to help secure the nation's critical infrastructure, including power generation, transmission and distribution, water utilities, critical manufacturing, and the oil and gas industry. The next steps for our technology is getting to TRL level 6. This will be accomplished through finishing our demonstration in our lab environment, demonstrating the technology in a large-scale commercial network, and finding a program for a Phase 3 transition contract to deploy the technology on Navy networks. At the same time, we will be working to transition the technology to industry by finding partners from a variety of sectors, including power, water, manufacturing, and oil and gas. The larger variety of networks and physical processes we see, the more we can refine and improve our algorithms to be even more accurate. So in conclusion, take a moment to consider what kind of impact could a nation-state level adversary have if they gained access to your ICS. Is your ICS network fortified? If you're interested in learning more, seeing a web demo, or have contacts that could use some help securing their ICS networks, please reach out to us or stop by a virtual booth. Thank you.